I'm Paul Hetherington. I'm one of the directors of BugLife, the Invertebrate Conservation Trust, the only organisation in the whole of Europe that stands up for all invertebrates. So I'm going to basically give you a very quick introduction to who BugLife are. Then I'm going to talk about why bugs are important. Then I'm going to talk about bug decline, causes of bug decline, and then we're going to look at some of the practical things that can be done on a personal level and on a more of an industry level to support the future of bugs on the planet. So that's kind of the plan. So let's get moving. My first slide, a very brief introduction to BugLife. BugLife is approximately 20 years old. The concept was born in 2000, but it didn't get off the ground to 2002. And we grew out of other conservation organisations. The government were doing their red listing of species back in the late 90s, and you had RSPB were there, and they said, well, we'll do all the birds, and butterfly conservation were there, and back then they didn't even do moths, so they said, yes, we'll do the butterflies, and suddenly they realised there was no one going to stand up for invertebrates. So they decided you needed an invertebrate organisation, and that led to the foundation of BugLife. And we're the only conservation organisation where our board of trustees are elected by representatives from the other conservation organisations, which means we're also very collaborative and we work a lot with others. But here's just a few of the things we've achieved. Because we do practical conservation work, we also campaign. So if I start in the, for you, top left, and that site there is actually Canvywick Nature Reserve, and it's the first site that was created as a triple SI for invertebrates. It's on Canvey Island. It was planned to be an oil refinery, and for some reason it never got built, but you've got some of the foundations in there, and it's provided perfect habitat for invertebrates. You also get great crested newts and quite a number of reptiles on the site. But the point is that site's got about 13,000 different invertebrates on it, including around about 50 of the red data listed invertebrates. Things like the shrill carder bee, which is probably our rarest bumblebee, are amongst the species found there. And that's a site that's now managed by BugLife in conjunction with the RSPB, and it's grown in size greatly since it was first created as a triple SI. That was after a long planning battle because originally they wanted to build stuff on it. And we managed to save it, and we've recently had another 100 acres added to it by Morrison's supermarket, who bought up the land adjacent to it to stop another superstore being built there to compete with their one, and they've handed that over, so the nature reserve's now got a lot bigger. Moving across, you see this strange looking tub of chemical. That's cypromethrin. Cypromethrin is a type of sheep dip, and BugLife did some research into it, and we basically found that one drop of that getting into a stream would wipe out all the invertebrates in that stream for 10 kilometres downstream of where it went in. So we launched a big campaign around it, and there is now a global ban on that being used for sheep dip because, you know, obviously if you wipe out the invertebrates, you're going to wipe out the fish, etc., etc. So that was a sort of campaigning success. The next one of our more iconic species. Does anyone hazard a guess what it's called?
Ladybird spider.
Correct, yeah, that is the ladybird spider. Anyone who's been on holiday down sort of Mediterranean areas may well have seen some of them because there's 4 species of ladybird spider in the world, and 3 of them you'll find down in the Mediterranean. This is the one that's found in the UK. It used to be found all the way from the New Forest right round to the lizard. We started work on it just over 10 years ago, and when we started work on it, it was on one site only, down on the Dorset Heaths, and that site was probably about the size of this room we're in. It was a very small area, and that was the only place in the whole of the UK where the ladybird spider was now found. After all those years, 10 years working on it, it's now on 19 separate sites where the habitat's being created, translocations are being carried out, and/or captive breeding carried out. And we feel that we now have a sustainable population of that species. So that's sort of, it's a 10-year process to get a sustainable population going of something that's highly endangered. Okay, now we'll move to this big yellow one in the middle. Does anyone want to have a guess as to what that might be called? No? Okay, it is fairly obvious in fact. So it is called the spiky. yellow, and it's a woodlouse. So it's the spiky yellow woodlouse. And spiky yellow woodlouse is one of around 500 endemic species. That means they're only found in the one place on the island of St Helena, because we have had some overseas work over the years, and one of those areas was St Helena, and we went out there, did some work to catalogue, find the local species and prepare them before they built the new airport on the island, which was going to damage the habitat. This is rather an iconic species, very, very sort of, pretty. But while we were doing that, we rediscovered a froghopper that hadn't been seen for over 114 years. Unfortunately, we didn't find any of the giant earwigs. If you've ever been to a museum, you might have seen parts of these really large earwigs, maybe sort of an abdomen that's that sort of long. They're again only found on St Helena, but they sadly have not been seen since around 1965. So probably extinct now, but you can never be totally certain with species because, as I said, we found this froghopper that had been gone since 114 years ago. And down in the bottom corner there, that's an oil beetle. And we've done a lot of work on oil beetles. Oil beetles are interesting because they're an indicator species of pollinator health because they're dependent on solitary bees for their life cycle. When we started work on recording them, it was believed there were 3 species of oil beetle in the UK. We now know there are 5 species of oil beetle in the UK. 2 of them were rediscovered as a result of doing that survey. Now, they're called oil beetles not because they are quite sort of shiny and oily in appearance, but when threatened they excrete an oil-like substance from their hind legs as a defence mechanism. But as I say, they are very good indicators of pollinators. Basically, they lay their eggs in flowers, like a dandelion flower. Solitary bees land in the flower, the eggs hatch, the little larvae crawl onto the bee's legs, fly off with the solitary bee. The solitary bee lays its egg, puts a pollen bundle into the hole it's made. Off comes one of the little larvae, settles down in there, the bee seals it in, the larvae eats the pollen bundle. Unfortunately, the bee doesn't survive because it's got nothing to eat, and out comes, at the end of all of this, one of these beetles. So if you haven't got a good, strong, healthy population of solitary bees, you're not going to have oil beetles. So that's why they're a really good indicator species. So that's just a few of the things we've done. We do a lot of work on pollinators, but more of that to come. So why are invertebrates important? Well, invertebrates make up around about 73% of the known species on this planet. Far more than plants, fungi, microorganisms, birds, and ourselves, who sit amongst other vertebrates, 0.4% of the known species on the planet. So because we have backbones, we very much skewed the system, if you like, by classifying vertebrates and invertebrates, which is why you have so many species of invertebrates. So huge, huge number of species. And you can see from that that obviously they've got to have a fair degree of importance that we have invertebrates. But invertebrates are facing terrible declines. And this I always find is a very interesting thing because we always hear about saving the rhino, saving the tiger. Land mammals, 15% of them are at risk. Insects, 41%, and if you look at some of these species there, caddisflies 68%, butterflies 53%. It's also quite interesting that a lot of those really endangered insect species are dependent upon fresh water for part of their life cycle, such as the caddisflies, the mayflies, the dragonflies, the stoneflies. Flies are doing all right, there's no surprise there. And one of the things we have discovered is that some of the more common generic species are doing well, but lots of the more specialised ones, they're the ones that are really at risk of extinction. But the thing is, we are facing an insect extinction crisis, and if we lose that lot, you will also lose that other lot there because they are so dependent upon one another. And I'm going to touch on the reasons for decline shortly. So why do they actually matter? What do they do for us? Well, they do all kinds of things. Pollination is probably the one that most people understand and know about. 1 in 3 mouthfuls that we eat is dependent upon pollinators. An awful lot of the ingredients in those sandwiches would not be here without pollinators. And you say, oh yeah, well, tomatoes, obviously, but you wouldn't have lettuces because the lettuces wouldn't set seed, so there'd be no seed to plant the next generation of lettuces. Same goes for things like carrots. And then obviously there's cucumber there, again, that's pollinator dependent. So we are very dependent on pollinators for what we eat. If we just in the UK lost pollinators, it is estimated that it would cost £2 billion a year extra on foods that require pollination to pay someone the minimum wage to go around and hand pollinate plants. Now, we're worried about the cost of inflation on our food at the moment. That would be astronomic inflation on certain food substances. So we'd be left with grains and potatoes and the things that don't require pollinators. Likewise, bird speaking, we would have the crossbill, which eats grass seeds, and one or two of the carrion type birds. Maybe even the red kite might survive because there'll be still things like rabbits and they could get them. But virtually all the other birds we would lose. So huge, huge impact just from pollinators alone. But they do so many other things as well. They break down organic matter in the ground and turn it back into fertile soils. And that goes for lots of different things that get broken down. So dead and rotting vegetation, poo, feces. Imagine what the world would be like without all the invertebrates breaking that down. You walk out your door and you'll be knee deep in it because nothing's broken it down. It's horrible to think about, isn't it? Bodies, they break down dead animal bodies as well. Yeah? All of that stuff is really, really important because it's breaking the stuff down and turning it back into nutrition, which in turn gives us nice, healthy soils, healthy crops. They are predators. They control some of the things we consider pests. And one of the great controllers of things we consider pests is something that most of you will consider a pest yourselves, wasps. Most people hate wasps. And I'm going to talk a bit more about wasps later on and why we really shouldn't hate them. But they are very important predators for keeping under control things like leather jackets and caterpillars. So really, really important to us. They have a role in filtering water and cleaning it. They control weed numbers. A lot of them munch their way through specific weeds to keep them under control. They are food for other animals. Daddy longlegs is a great example of that. The crane fly, for more proper terms for it. And everyone kind of wonders, well, what's the purpose of them? And some people are worried they can bite or they can sting. Now, the thing that people sometimes think is a sting is actually the ovipositor. And if you see something with the ovipositor on it, it's obviously the female. So it's actually quite easy to tell the male from the female. If it's got that little thing that people think is a sting, it's a female. If it hasn't, it's a male. They only live for 24 hours because they can't bite you, they don't have a mouth. They can't drink, they can't eat. They are basically sex machines, if you like. That is their pure purpose, is to breed, to lay eggs, and then you have their larval stage, which will be a year to 2 years underground. We call them leather jackets, munching away, eating, particularly grass roots is one of their favourite things to eat. But the adult form, very, very short-lived. The stag beetle, one of our most iconic beetles in this country, you'll only see it in the sort of southern parts of the country, you don't get them up north. They have these fantastic antlers. They will live in their adult form for approximately 2 weeks, and that is all. They will spend 7 years as larvae eating rotten wood in old tree stumps and so forth. And the reason they don't last very long is because yes, they have a mouth, but they can't eat because their teeth, their mandibles, using the proper term for them, are those lovely horns. So they can't chew anything. So they look very impressive, but they can't eat. So the only sustenance they can get is by drinking water, and if they're very lucky, they might find sap runs on trees, and obviously you can get sugar from it in the same way we get maple syrup. So very, very important role that they play in breaking things down, and they and plants are really the backbone on which all life as we know it is built, but things that we tend to take for granted. In many ways, if you're in a big business, you've probably got a sort of an admin team somewhere or a finance team. And well, what do? They don't go out and make sales. They don't manufacture anything. But if they were just to disappear, you'd certainly notice they were gone. And that's kind of the role of invertebrates. We tend not to appreciate them, but they are totally invaluable to the running of life as we know it. So what have we done? Well, we've been mapping what we call the important invertebrate areas. These are areas that are really important for invertebrates. Now, all of this information is available on our website. Sorry, the rather blurred one there is a screen grab. All of those red blobs are important invertebrate areas, but those are at a 10 hectare level. And this little one down here gets fine scale mapped, and this is what you'll see, and that takes you down to a sort of field level of where those important places are. Now, we've also now created habitat management guides, and the next phase of that is really to go out and speak to people about these are important places not to destroy, but these are also important places to consider if you're doing something in those areas, then maybe you can plant something specific that will help to spread those very rare species. A really easy to explain example is a wonderful beetle that you'll find in the Brecklands. It's called the wormwood moonshiner. That's just such a fantastic name. There's lots of inverts that have got great names, really. The wormwood moonshiner beetle eats wormwood. No surprises there. Wormwood is also very rare. We have found that if you bring in the wormwood plants in that area, the beetle will appear, to the extent that we found a roundabout on the, I can never remember, it's the A46 or the 47 that runs through the Brecks, covered in wormwood, and it's now covered in beetles. So that's the other great thing, you can see species recovery very, very quickly. So that's sort of important invertebrate areas, and that deals with all invertebrates. And now, if I can get this to play properly, I'm going to have a little break from talking to you while you watch a little video about beelines.
We all see wildflowers as beautiful and great for our well-being, but for the thousands of pollinating insects that share this land with us, wildflowers are vital. But there's a problem. Pollinators are finding themselves in isolated oases, walled in by agricultural land, urban landscapes, roads and gardens. What humans see as neat and tidy, insects see as desert. Since 1940, we've lost 97% of our flower-rich meadows, and hundreds of our pollinator species are in decline. At BugLife, we have come up with a beautiful solution to the problem: beelines, a network of insect pathways along which we are restoring and creating wildflower-rich habitat. These insect superhighways will extend across the whole of the UK, allowing wildlife to move freely through our countryside and towns. But we need your help to make it happen. Restoring fields of wildflowers. Making space for wildlife in our towns, on road verges, local parks or gardens. Mowing the lawn less often. It's the easiest thing you can do for your local pollinators. Or how about planting a wildflower meadow in your local park or school? Then add your project to the Beelines map. Help us make our network of habitats bigger, better and more joined up. Find out more at buglife.org.uk. Saving the small things that run the planet.
So I always play that video rather than talk you through it. One, because it gives me a break from talking. Two, because I think that just puts over the whole concept of beelines really well. That 97% of wildflower-rich meadows, to put it in a perhaps more easy to conceive way, is equivalent to roughly 1.5 times the area of Wales. So it's a huge amount of land that's been lost. The idea behind the beelines is that, yes, we could all randomly put in stuff for pollinators around the country, but if you do it in this planned way, you need only 10% of the land that you'd have to do if you were just randomly putting it there to restore connectivity. And this is what I want to talk about. Sorry, I had to pop onto the next slide to stop the video playing again. This is why I wanted to talk about the causes of decline. The causes of decline are loss of habitat, as you've seen there, loss of habitat connectivity. Again, beelines is there to address loss of habitat connectivity. Those are the two biggest causes of insect decline. After that comes our use of chemicals. And I'm using the word chemicals because it's not just about pesticides. Herbicides are just as impactful as pesticides are. Those of you who drive through the countryside, particularly arable areas, you will see England's green and pleasant land, but it is just generally green, fields of wheat. There's no wildflowers growing in them anymore because of the herbicides have wiped them out. There's no food there for pollinators. And it's a sad fact that there is now more diversity of bee species found in our urban environments than in a lot of our rural environments. Climate change is another impactor on our numbers. Bumblebees in particular are affected by warming of climate. They like a temperate climate. If you go down the Mediterranean, you will find just 2 species of bumblebees. We have 25. France has 47 species. A lot of our species are now moved up to the Cairngorms and further north, but now they can no longer move as things get warmer. So you have things like our rarest bumblebee, the shrill carder, which is trapped in these little brownfield pockets down in the Thames Gateway. You also find it on Salisbury Plain, Somerset Levels and a few brownfields around Cardiff. 30 years ago, it was the most common bumblebee in southern Britain, and it's now reduced to those few sites. So very, very in danger, can't get away. And bumblebees are particularly susceptible to climate change because the normal pattern for bumblebees is that they will hibernate over winter. So you have one generation, spring, summer into autumn, new queens, then fly off, hibernate over winter, and then the cycle begins again. What we have found is that now they're not often hibernating over winter, so they're trying to start colonies in winter. Big problem, there's not a lot of food out there in wintertime for bees. So it's a really horrible cycle of decline because a lot of these colonies that set up in the winter fail. So then there's less queens to start colonies in the summer, which means there's less to overwinter and or start colonies in winter, which again fail. So it's a horrible cycle of decline that really needs to be addressed. And then the final thing that is affecting our species is the introduction of invasive non-native species, some of which can be very, very damaging. An obvious one is flatworms. And we have now got at least 17 species of flatworms that have predominantly come from Australasia, but we've also got some that have come from South America, have got established in the UK to the extent that they've been found on Dartmoor. And it's known that if you get flatworms in the area, your earthworm population will drop by 20% because flatworms eat earthworms. None of these are native to this country, but they've now got here. Or another invasive species that you'll probably be aware of is the chestnut leaf miner, which is a moth. And you may have noticed in parks and places where there are chestnut trees, the leaves start to go brown, maybe in June, July time. And basically the chestnut leaf miner lays its eggs between the layers of the leaf. They hatch out and then the caterpillars live within the leaf layers. And if you actually take one of those browning leaves and pull the layers apart, you'll find the little caterpillars in there. The horse chestnut comes from Macedonia. The moth comes from Macedonia. The moth got into the UK somewhere around about the year 2000 in the Wimbledon area. They are very, very poor flyers. They tend to walk mainly. It's now found in Northern Ireland, Southern Ireland, all over the United Kingdom. The only way it could have spread so fast is it hits riders in cars and things like that to spread around the country. Otherwise, it would probably only just be reaching the M25 at the natural rate of spread of that moth. And of course, it's a huge problem here because in its natural habitat, there are predators that have developed to be able to pull these larvae out from within the leaves, so it keeps them under control. In the UK, we have no such predators, so it can run amok and it creates havoc with things. I now want to talk about pollution, and I want to talk about light pollution, which is in many ways the last acceptable form of pollution, but something we can really think about with the built environment. And it's a problem with ALAN. I hope there's no one called Alan in the room. ALAN stands for artificial light at night. It is known that 1 in 3 insects that are impacted by artificial light at night die as a direct result. Either they crash into something, they burn up on something, or they fall very much more easily as prey to things like bats and birds because of the attraction of artificial light. Artificial light has a huge impact on bird populations, bat populations as well, but I'm here particularly to talk about its effect on bugs. Another thing that's happened is, those of you who are old enough to remember, we used to have lots of sodium lights, and they had a sort of yellow glow to them. Nowadays, most of our lights are these modern diodes, so they are bright white lights. Unfortunately, bright white lights have far more impact on invertebrates than the old sodium lights did, because a lot of the invertebrates didn't really see in that sort of sodium yellow end of the spectrum. So they weren't impacted by it in the way they are by modern lights. The other thing is, modern lights, low energy, but often much brighter output. Now, of course, there is a play-off here because lighting is important for people to feel safe. And we've been actually doing a lot of work with Network Rail, where they've been experimenting with different things to do. So it's looking at lighting being more directional, because often our lighting is omnipresent and we light everything up when there's no need to. So it's about thinking about directing the light where it's needed, thinking about whether your light can be triggered by motion sensors, or making sure that it's on timer switches. And even when it comes to doing line side work now, they're looking at being much more directional. And I will shortly get a report back from them about how it's gone, but they're talking about they've actually had massive cost savings to the business from doing this, as well as obviously the benefit on wildlife of controlling that artificial light. So that's something we can all do, and even in our own personal lives. If you have outdoor lights, only have them on when you need them on, not all the time. And a lot of people buy these outdoor solar lights and put them in their gardens, think we're being really green and good. But they're on all the time, and you're actually doing a lot of environmental damage with light pollution, having lights on when you don't need them out there. If you put a light on in the house, draw the curtains, and then your light isn't spilling outside and having an impact. So some very simple, no cost, low cost, or even positive to you cost things you can do in your own lives and around the design and development of new buildings. What else can we do? Well, there's all kinds of things we can do within our gardens and home areas. And what I'd say to you, even if you don't have a garden and you live in a flat, could you get a window box? And if you have a window box, if you look what's down there, I would always say plant herbs. Herbs are absolutely brilliant for pollinators if you let them flower. They're one of the best things for pollinators when they're flowering. As good really as wildflowers. And the reason I say plant those if that's all you can do is because then you can pick some of those herbs and use them in your cooking, and so you get a benefit as well as the insects getting a benefit. You say, well, what use is it me putting that box there? Well, think of it as a motorway service station that you've created, and what you've done is we've got one good area for pollinators and another good area, and the distance between them is too big for them to move from one to the other. Your little motorway service station will enable them to pop in, fuel themselves up like we fill our car up, and make it to that next destination. So even that little act carried out by yourself can make a huge positive impact for our pollinators. Flowering shrubs are brilliant. A lot of trees, particularly flowering trees, are brilliant. I'm talking of flowering shrubs. I mean, think about hedgerows, blackthorn. Blackthorn is one of the earliest flowering plants in the UK, and if you go around in sort of February, March time and the blackthorn comes out, you will find them covered in very large bumblebees, and those are the queen bumblebees who are going to set up the colonies. So it's a vital food source for queen bumblebees to establish colonies. Another interesting thing about queen bumblebees is you may often see them flying around sort of a foot or so off the ground over areas of grass. You know, what on earth are they doing? There's no flowers there. They are sniffing for stale mouse urine, because their favourite place for making a nest is in old mouse holes. So they are sniffing out stale mouse urine to make a new home to start their colony when you see them doing that. Ponds are really good. Now obviously if you've got children, ponds can be a bit of an issue, but even a bird bath is great. And why do insects need them? Because just like us, they do need to be able to drink, and solitary bees need to use it to seal up their nest holes. Have some bricks here for solitary bees to nest in. They can nest in there, but they have to seal those holes off. And about half of the things that would use them will use mud to do it, so they need bare earth and they need water. The others are what you call leaf cutter bees, and they cut little shapes out of your leaves, and you can actually identify what type of leaf cutter bees you have from the shape that's being cut out of your leaf, because different ones cut different shapes out of your leaves. Let your lawns flower, put in wildflowers, put in bee hotels. Water butts are great, conserving water. Compost heaps will be full of invertebrates. So there's all kinds of things we can do when designing a garden or in our own garden spaces. I also want to talk about vertical meadows. It's a new concept that we've been involved with, and it's been trialled up in the sort of Camden area of London. You've probably come across living walls before, and one of the things that's always struck us about living walls is most of them are made out of lots and lots of plastic pots. And if they're not made out of lots and lots of plastic pots, they're made out of this sort of sacking material. We've all heard about Grenfell and what happened there. If the water supply breaks and the plants die, those vertical walls are highly flammable. So we've worked with a company, helpfully called Vertical Meadow, to develop the Vertical Meadow. It's a whole new system. So your wall is made out of these aluminium blocks that have got like tea bag perforations in them. Inside that is rock wool. It's like loft insulation, only loft insulation repels water, rock wool holds it, so that holds the water in. And then you just put seed paper with your meadow inside there, the seeds germinate, they come out through the holes and the structure stops them blowing out, and we have managed to create successful flowering meadows, and all you have to do is cut them once a year and you've got the equivalent of what you'd have on the ground, but going up your wall. And as you can see, there's hoverfly on there, we've had butterflies, we've had bees. So we're really, really pleased with that as a sort of prototype idea of something that can be done. So even in the most urban of landscapes, you can do that. Do you want to ask a question?
Building control consider that to be non-combustible?
Sorry?
Building control consider that to be non-combustible?
It's been tested by London Fire Brigade and it's got a very high fire rating certificate, yeah.
Is there a happy with it generally?
Yeah. Yes, I mean, that was one of the things that we felt was very, very, and not only have we tested it, we actually turned the water off and let the vegetation completely die off in one bit, and they tested that and it was still considered a really good fire rating. Whereas, as I say, most conventional ones, there is a lot of worry around them. So that's Vertical Meadows. Kind of expensive to put on your houses, but if you're building an office block or something like that, really worthwhile considering. I mean, I suppose the other thing is if they can get into more mass production, costs will come down. But you're looking at somewhere around £500 a square metre to start with. Living roofs. Living roofs are also a really great thing. Bug Life produced about 10 years ago creating green roofs for invertebrates, and that is still considered the best practice guide in how to create a green roof for invertebrates. And on the other side, we have a picture of one that was being created at a school up in Scotland. And it's got access for people in wheelchairs. That's hence the path going through it. Has proved really, really popular. We've made a massive one at Grangemouth on top of a big industrial factory there, about 200 square metres. Living roofs are actually not expensive if you build them. They are very expensive if you retrofit them, because if you retrofit them, you've got to do a whole structural survey to see what kind of weight your roof can take. If you're building from scratch, you can build the roof to take them, and the actual cost of putting them is much, much smaller. So retrofitting, much more expensive than a living wall. If you build them into your design, much, much cheaper than putting a living wall up there. And of course, we've also done work more recently on what we would call a bio-solar roof. So you will have this kind of vegetative structure, but you also have solar panels. So you've got the best of both worlds. Now, here's a couple of very interesting things I've come across. I'm going to start with the signs. That is a normal road sign, but as you can see, built into the back of it, they've got little homes for solitary bees and a little tray into which you could put some plants and things. So a very sort of novel idea. I think they're made in Germany, but I've recently been in contact with someone. I thought, this is a really interesting concept. I wonder if it'll take off. I would say that the positioning of such a thing is very, very important. If you're putting a solitary bee home up, it needs to be south-facing or as near to south-facing as possible. Otherwise, it's not going to get used. You say, well, isn't it a bit hot? It is, but it's all about winter. And if it's not as near to south-facing as possible, in the winter, it gets too cold, the larvae die, so therefore it doesn't get used. But this is what I really want to talk about, this wasp control here. And I said I was going to come back to wasps, and I am now. So wasps get a really bad press, and here I'm talking about the social, solitary wasp. Most people don't even realise they're a wasp. They don't sting, and they just go about their business, killing caterpillars and so forth. But social wasps do a similar thing, and I'm just going to tell you the story from the wasp perspective. So the queen wasp sets up the nest, starts to build it. They make paper by chewing up wood, and they create paper. They made paper long before we made paper. Very, very clever. And she lays eggs, and the first eggs that hatch are going to be worker wasps. And all worker wasps are female, by the way. The worker wasps then go out and start to bring back food and help to build the nest bigger. The queen continues laying eggs, and quite a few of those eggs are going to develop into new queens, which will be the following year's generation. These worker wasps have basically been born into a job for life, something that doesn't seem to exist anymore for humans either. But they've got a job for life. Go out, bring back some food, feed it to the growing larvae. So off they are, job for life, and when they hand over that caterpillar or leather jacket or whatever they brought back to feed them, the larvae excretes the wasp equivalent of honey, a little sweet nectary substance. And the wasp says, this is very nice. So, job for life, I'm addicted to something I can't get anywhere else. And then in August, and the warmer the year, the earlier in August it happens, all of the developing queen wasps have finished developing. They fly the nest to go off to feed themselves up and find somewhere to overwinter. You have effectively got mass unemployment, a group of creatures that are addicted to a substance they can't get anywhere. Oh look, we've got cans of Coke, bottles of beer, fizzy drinks, sweet things. This is what the wasps are after. So they come after these sweet things. The other thing they tend to do is, because we're generally quite tall, wasps like to geolocate where they are. So they'll often fly round and round you, particularly if you're moving around. So they'll fly round and round you, you move, they'll fly round and round you again. And we tend to panic and start to flap our arms about. And that just upsets the wasps, because they're actually just using you as a marker point to know where they are. So if you stood still, they'd leave you alone. The other thing is, at this time of year, you get a lot of ripe fruit. Things like blackberries are on the bushes, and wasps can also get their sweet stuff from them. But once a piece of fruit is ripe, it has started to ferment. Now, I doubt anyone in this room could eat enough ripe fruit to get drunk from it. But wasps are much smaller than us, and they get drunk. And unfortunately, they are bad drunks. So they are bad drunk addicts who had a job for life and are suddenly suffering mass unemployment. If they were humans, you'd get them a social worker. Because they're wasps, we think they're horrible and they're pests, and we try and swat them and we kill them, and we send exterminators in to kill them. This man, and I'm going to meet him on Monday, I'm going out to Ireland. I'm playing croquet, actually, for England against Ireland. But I'm staying over the Monday to meet this man, and he's developed this wasp control mechanism. This does not kill wasps. What it does is it provides a feeding station that gives them a really nice, sweet substance, just like they want. But it's not as nice as what the larvae exude, so they'll continue doing their job, bringing back larvae, feeding them, and when that's over, these machines get turned on, the food's coming out. It's been tested in Ireland's greatest theme park called Tayto Park. Seriously, look it up. They put in 2 machines last year, turned them on, and the number of stings per day dropped from 15 stings a day to 1. They have worked out that if they put 4 up, there'll be no stings a day. Now, this will not work on a household scale. If I put one in my garden, all the wasps from about a 1 kilometre radius would come into my garden, and I'd probably get worse stings. But they work on a more municipal basis. So, I mean, if you had a village, if you put a couple of them in the right places where people don't need to be, you would actually remove the wasp problem from people. And I just think this is such a fabulous idea that this person has developed and tested and proven to work, that I had to bung it in. And it wasn't in the original presentation because I met him after I pulled that together, so I had to add this extra slide and send it along, because I think it's just a fantastic thing, so is Tayto Park, really, isn't it? But yeah. Building for bees. This is something else you can do when you're planning buildings. It is putting these, some of them here behind me, these structures into buildings. Now, why do you need to do that? Well, an awful lot of solitary bees traditionally would burrow into sandy cliff banks and similar structures. Most of those have now been taken away because we've extracted the sand to carry out our own building works. However, when we first started building, we used what was called lime mortar. Now, lime mortar is kind of fairly soft, and solitary bees are able to burrow into it, and we're able to nest into it. So we kind of got rid of their habitat, but we created a new habitat that they can use. Modern mortars with their cement base, they cannot burrow into, they're far too strong, and that's why we've moved to them, because they're much more resilient. I've got a house that's got lime mortar in it, and yeah, it needs repointing on quite a regular basis, etc., etc. But they can't get into them. So we took away their original habitat, but gave them a new one. We've taken that away, so now we need to give them a new habitat. And putting these bee bricks in is a great way of giving them a new habitat. But as I always say, it's about orientation. They've got to go in as near south facing as possible to get used. And you also do need to create forage. You can't have loads and loads of bee homes and a car park of concrete because there's no food for them. And the solitary bees that use these kind of homes will probably only travel about 300 metres in search of food. That's the limit of their range. A bumblebee go about 2 kilometres, but most solitary bees, it's around 300 metres, which is where we then come to your window box could extend that range because they can pop in, feed up there and move on further afield. So that's why your window box is important, but really good to consider putting these into structures. Now, you're going to say, well, people worry about bees, and yeah, unfortunately they do because they think they can get stung. There's roughly 250 species of solitary bee in the UK. Only 2 of those species are capable of stinging people. None of the others can even sting people. The ones that nest in this type of habitat, none of them can sting people. But it is a bit of a, the developer has got to get that across to people that the type of bees that are going to be using this cannot harm you. They're just really good for the environment, good for crops, good for everybody. But they are great things to look to incorporate into buildings. Bug homes are also great things to put up on sites, on the side of your houses. Again, it's all about orientation, and they come in all sorts of different shapes and sizes that are available. So in the middle is a sort of smaller one. That's the kind of one that you might put up in your own garden or area. And then those 2 larger ones are the sort of things that would be put in communal areas. And again, it's all about the orientation, making sure they're south facing. Now, some of you may be aware that a lot of people say, well, yeah, the problem with them is that you get a build-up of pests and diseases in there. And that is true. Yeah, and research has shown that after about 3 years, you will have got a build-up of mites and diseases within a bee home if it keeps being repeatedly used. But it doesn't present a huge problem because the bees seem to be aware of this and they just stop using it for 2 or 3 years, and then they'll start using it again because the pests, etc., have gone down. So things like your bricks are fine. If you've got something like the solitary bee home there, then you either go through that cyclical, about every 3 years you'll have a break from it being used, or you can take all of your tubes out and replace them. If you do that, you should store the old tubes in a box in a shed, and then in the spring bring them out so any bees that have been laid in there will still be able to hatch and get on with their job. And you don't have to buy bamboo canes and cut them up. Dried river reeds are just about the perfect habitat to put into one of those, and you can probably pick them up for free somewhere to restock it. Or if you wanted to, you can actually clean them out with pipe cleaners to get rid of any problems in them. So there's plenty of things you can do with bug homes. But even if you just put them up there and you don't carry out any maintenance, somehow the bees are aware of what's going on and it sort of self-moderates. So maybe if you put 3 up and 1 every year, you'll have a constant supply of at least 1 of them's in use. You can, of course, make your own, and there's all kinds of ways of making your own. Old pallets stacked up and, put through lots of building rubble is actually quite good for invertebrate habitats. Old bits of wood, log piles are brilliant. Old leaves and things, sort of mimicking a compost heap. Make your own bug home, and someone's drilled a lot of them. Those are just little sort of things of hollow sticks that have been put together. Again, makes a great solitary bee home. Hanging from the tree, old plastic bottle, bottom's been cut off, corrugated cardboard put in there. That is an overwintering place for things like lacewings. Lacewings are very, very important for controlling aphids. Just like ladybirds, they have a voracious appetite. A ladybird might eat 5,000 aphids in its lifetime. A lacewing, something similar. Hoverflies also, the larvae of a lot of the hoverflies eat aphids. So there are a lot of things that help control pests. And then you can get creative as well. The small one at the top there is a Millennium Falcon bug home. We had a competition up in Birmingham for people to design bug homes, and that was the winner. And people came with bug homes in all sorts of different styles and designs. As long as the habitat part works, you can do what you want with it to make it pretty, to make it enjoyable, to make it fun. And what else can you do? Well, you can get involved in surveys. And there's 2 surveys that anyone can get involved with. They're very, very simple to do. Bugs Matter, one on the left, and this one is one that's run by ourselves in conjunction with Kent Wildlife Trust. We did it for the first time last year, and we found a 60% decline in flying insects since 2004, when the same survey was carried out. It's a massive drop in under 20 years. And this is an app. You can have it on your phone. So it downloads onto your phone as long as you haven't got a Windows phone. It only works on Android and iPhone, but I don't think much works on Windows phones anyway. Yeah, and that 60% doesn't tell the whole story. For England, it's actually 66%. You go down to places like Essex, Kent, you're looking 70, 80% decline. Up in Scotland, you're only looking at about a 30% decline. So you can also see, you know, how the declines vary across the place. The more people take part in that survey, the more accurate data we get out, the more we are able to say the problem is in this area, we need to do something here, and or we need to connect these areas up so things can travel through this particular area. So that is something I'd encourage people to do. Literally, once you've downloaded the app, you get sent your splatometer in the post. I'm hoping that by next year, you won't need a splatometer. We're working on the app to be able to put the splatometer on itself. And we look at number plates, and the reason we look at number plates is it's based on the old talk where, you know, oh, when I was a lad and parents used to take me somewhere, they used to have to stop the car and wipe all the squash bugs off the windscreen. Now, windscreens on cars are in all different orientations. Number plates are always in that one orientation, vertical, and they're all the same size and shape. So it's a very even thing to measure stuff on. So that's why we use that. We don't want the whole of it, because that would be giving away on a photo too much information. So you use your splatometer, you put it over it, and you count the number of splats within that grid. Again, the development that will happen on the app over winter this year will mean that that grid will be imposed by your phone, so you don't have to hold anything up against it, and you don't pin it on for the whole journey like some people think. You just hold it up at the end of the journey. You need to clean the number plate at the start, and you take a photo of it and you count how many splats there are in there. The photos are actually being used to train the artificial intelligence, and what will happen is you just hold your camera up, take a picture goes up, and the artificial intelligence will be able to count for you. So literally then all you will have to do is to run the app when you're traveling. And the reason you run the app when you're traveling is it actually tracks your journey. So we know exactly the route you've taken when you've gone somewhere. So it gives us a lot more information. And we've also pulled into it various factors to allow for changes in car aerodynamics. And most people think, yeah, modern cars, much more streamlined, you'll get less splats. Well, actually, we found out that modern cars, you generally get more splats than you do on the older cars. They may be more aerodynamic, but for some reason, you're getting a lot more splats on a modern car than an older car. So that's Bugs Matter. I'd encourage anyone who hasn't to download it and give it a go. It takes approximately 2 weeks to get your splatometer sent to you, but the survey runs until the end of August, so there's still plenty of time to get involved in it. The other one that's really easy to do is POMS, the UK Pollinator Monitoring Scheme, and doing what we call the pollinator fit count. And that's about a 10-minute job. And again, there's an app now you can download on your phone, and you can do it all on your phone, so you don't have to use paper, you don't have to go back to a computer. And basically what you do is you pick a 50 centimetre square bit of ground that's got some flowers in it. Now, it works at whatever level you are. So here we have a 50 centimetre square, those are dandelions. But if you didn't know they were dandelions, you can just say yellow flowers. Because what you need to do, say there was some purple flowers in there as well, you need to pick one flower type that's in your square, and then you watch for 10 minutes and you just record everything that visits the flowers that you've chosen, so the yellow flowers or the dandelions, during a 10-minute time period. And if you can identify things, you can tick them off as, I've seen a bumblebee, I've seen a solitary bee, I've seen a honeybee, I've seen a hoverfly, but it works to the level of I've seen a flying insect. And people all over the country are doing this, and this is part of how the government are pulling together information on the state of our pollinators across the country. So again, something that's very simple, quick and easy that we can all do and we can all take part in. So stuff you can do on an individual level, and stuff you can do when you're thinking about designing places, building places, moving forward. And that's the end of my presentation, so I'll open it up for questions.